picture of some phenolic things. So
yeah, it looks fun.
It's one I used in a video ages ago. Well, not that long ago actually. But there's a cutout electricity meter and a fuse box, and they're all made of phenolic materials. So what a nice set of complete disasters waiting to set on fire.
John, is that a meter board I gave you that you cleaned up?
Yep, that is the one.
You did such a beautiful job of that. Can I have it back now? Can I put it back on the wall? That's gorgeous. Yeah, that is phenolic as well. Do you know what? You're absolutely right. It is totally phenolic. Hello, everybody, and welcome to another E5 podcast. I am Paul Meenan, your host today, and I'm joined by my regular tag team partners. Please say hello, chaps.
Hello, I'm JW.
And it's me, David, Sparky Ninja.
And he's actually joined us for this sequel to our Earthing podcast. Thanks for being with us, Dave. I know you've been busy doing webinars, and we've all been doing webinars, and it's been an interesting summer. And well, we're autumn now, I suppose, winter, whatever time of year this actually comes out.
It's amazing. It's amazing that how you start doing a couple of webinars, but then you realise there's more things to talk about as you unlock more subjects. So I didn't anticipate to keep carrying on this way, doing webinars and things.
I haven't given you my list of new webinars that we've got to do. No, do you know what? You're absolutely right. I have to say the webinars for me have been an amazing self journey of discovery, because you're right. I like the format of engaging with peers, working with my friends to understand my own limits, push my own limits, talk about things, enjoy things, have a laugh about things, seriously discuss, be questioned and questioned back. I think it's only a good thing. So for anyone listening or watching, if you haven't watched any of the webinars, we've done them on DNO, commercial, industrial, SPDs, fire, and whatever else is available, and they're on the E5 and Sparky Ninja channels. So please check them out. If any of what we're about to say confuses you, there's some visual representations to help. But today we're going to carry on our chat about earthing, because earthing, for me, compared to what I knew 12 months ago, is totally different. I don't look at earthing as the same that I used to, and that's because I'd always considered the general mass of Earth, or in electrical terms, Earth, to be this place where fault energy goes, overcurrent energy goes from my electrical installation and allows my protective devices to trip and to function. But now it would appear, it's fairly evident, that if you are a practicing electrician or an inspector and tester or whatever, that if you just take a clamp meter in some, be very careful with that wording, some electrical installations, you can measure leakage. In the more newer installations with more digital technology and all the rest, you can use some very clever mega or fluke clamp meters to work out the loading, the leakage of the installation, work out the leakage to earth, and you can even then start experimenting so that you can figure out, your no more than 10 milliamps leakage per circuit rule. There's all sorts of additional thought processes that has to go into selection, erection, and when it comes to dealing with how we connect the fixed installation into earth.
But the thing is, I mean, we've had 20 plus years of being shown 3 earthing systems with the same illustration being done again and again. And so we are still, even in today's training, told to look at the service head to identify if it's a TNCS or TNS respectively.
Yep.
The truth is, it's not that easy now.
It's not.
Yeah, that image thing with the 3 types, that EV course I did a couple of weeks ago, that was one of the questions in it. What's this type of earthing? And it was the same manky old image from goodness knows how many decades ago. And it's like, yeah, well, and those 3 pictures of the TNS, TNCS, and the TT, while they're not wrong, they're horribly simplified, and quite frankly don't really represent what's going on in the real world. It's just a little tiny fragment of what actually can go on and what usually does go on.
So allow me to quote why my mind is boggled. If we look in 7671 page 28, the very top underneath the definition of duct is earth. An Earth is defined as the conductive mass of the Earth, whose electric potential at any point is conventionally taken as 0. Okay, so that's the theory. The electric potential is 0. But John, let's take one of the examples we spoke about in an earlier podcast, TNCS, Terra Neutral Combined Separate, so combined in the cable, known as a CNE or PEN. That is then separated within the installation. Now, if that cable combined neutral and earth becomes broken or damaged or high resistance, what can happen within an electrical installation?
Yeah, that particular one is where, so you've got the two things are linked together, so your neutral and earth are just linked, and while it's connected correctly at the other end back to the transformer, then it usually works. But as soon as that's disconnected, you haven't just disconnected the neutral, you've disconnected your earth as well, and now what was the neutral is now all of the metal things in your installation that were connected, what you thought was earth, and because you've now got a link between those going back to the equipment in your installation, you're going to get a dangerous voltage showing up on what you thought was the earth terminal of that installation, and that also includes any other metal items which happen to be attached. So in that case, earth isn't at 0 potential anymore. It could be anything from 0 up to whatever the voltage in the installation is, a couple of 100 volts there.
But I mean, this is a scenario that Paul just said. If it's damaged, I mean, is this? I mean, how do electricians now need to consider damaged cables? Do we have to think about the potential for cables to be damaged? How many cables are being damaged roughly?
And that's a valid point, Mr. Watts. I would like somebody to explain to me exactly what they mean by the term. And this is just analysing this. So the definition of Earth, again, I'll repeat this for everyone listening. The conductive mass of the Earth, whose electric potential at any point is conventionally taken as 0. So what exactly do they mean by conventionally? Is that basically saying, well, it should be 0? Now, I can tell you now that the 1989 Eastern Electricity and London Electricity PME guides do have references, I need to dig them out, do have references to the general mass of Earth not being at 0 volts and generally being saturated with energy. Because at the end of the day, these are paper insulated lead cables on the older ones, combined neutral earth on the newer ones, and they are transferring energy back to the substation and to the star point of the transformer where it's dissipated into the general mass of Earth. But TNCS is also known as PME, and the PME is part of the TNC part. However, it can only be PME if it's actually earth spiked. Now, this is a question for everyone listening. When you've gone out and watched a jointer, and we all have in our career watched the jointers in the street, and they join an old cable, or they join a new cable to an old cable, or repairing a damaged cable, how many times do you see them spike? Now, the reason I say that is I've recently asked UK Power Networks, who are my regional electricity company, if TNS as a system exists. Why? Because I have watched very recently a old paper insulated wrapped PILC cable, which is the lead sheath with the old BS951 clamps on them, which came into a property. It was a rather large supply, and it was a TNS. By definition, it was a TNS. By every fibre of what I've been taught from college, it was a TNS. Directly opposite on the other side of the wall in a hole 2 meters down, it was jointed onto from a 4-core copper and lead sheath to a 3-core and copper concentric cable. So by definition, the neutral and earth were linked just outside the building. So that earth became also a line conductor. It became the neutral. Now, in theory, fault current flows one way. In theory. But if that cable that you've just jointed, or a cable further down towards a substation, or the first joint for the street of houses becomes damaged, then that neutral return current may not want to go back to the substation. It will look to find another route. That other route potentially could be into a very nice juicy gas or lead water pipe, which is in my property, in which terms, you then have a phenomenon known as neutral current diversion, because that circuit for that property and that system is damaged. So that neutral current has to find a way to get back into that transformer, and it may find it goes through another building, into that installation, onto a water pipe, back down into the street, back up into another property, and then bypassing that damage in the cable. We're not taught this. We don't think like this, but this is an issue that is known in the electrical industry, in the DNOs, and is just not spoken about.
So DNOs do not need to repair cables to the legacy earthing system. They don't have to honor the existing earthing system.
So that's a very good point, and I will read out we'll find it. So under the UK Power Network Standard, section 5.3.2, there is a section called SNE Services, which is separate neutral and earth. To us, it's that old lead bitumen wrapped cable. And it says where a separate neutral and earth cable is to be completely or partially replaced. By the way, they never really ever completely replace it. And the premises supplied has a cable sheath, TNS, earth terminal, provided by UK Power Networks. The customer should be given the opportunity to have a PME, earth terminal, made where practicable. So I'd really like to know how it's not practicable, because that's a conversation and communication that needs to occur. If the option of PME terminals are chosen, it will be necessary for the customer to arrange for their installation to be checked to ensure it's suitable for connection to a PME network. Now, that's quite worrying in itself, because what that basically tells me is it's down to the customer to alter their electrical installation to comply with PME bonding rules, which to me is just Tefloning the cost and responsibility onto the homeowner or the consumer in some way, which for a network problem. But at the very bottom of this paragraph, it says if the customer does not wish to adopt PME, the existing single neutral and earth and the TNS earth terminal may be retained. And then it says refer to ECS 060026 for further information. That option is never given.
But if they're retained, but you're under the ground outside still putting in that combined cable, your earthing system's changed still.
Yes, it is. It's PME by definition, and this is one of the problems. So I have asked questions of various senior people in the industry as peers to try and understand this better, because I wasn't taught to think like this. And most what electricians would be, you expect earth to be conventionally taken as zero. Now, zero as in 0 volts.
Well, yeah, we need to come back to that. I mean, 0 volts is assuming a reference of 0 volts due to the electrode going straight in the ground and there being nothing else but another electrode right at the transformer. But there's no other energy whatsoever in the ground nearby.
What about current? Why do we not mention current? If you look for references to current, you will see very little talk about impact of current, which is ever so slightly worrying, to say the least. Let me see if I can find. Let me just throw another zany thought process at you. Live part. So I've just said we potentially can import neutral current diversion. It's a risk. So when you're putting a clamp meter on an electrical installation, you could potentially be measuring leakage from the installation, which is easily solvable. You can ascertain whether it is leakage, because you can just isolate the electrical installation, hopefully with planning and permission and safe systems of work, and then go ahead and check that again to see if you are picking anything up. That's when you'll really truly know that measure. And there are photos on our Instagram page, I think, of
this is where
recording of
the system's isolated, the service fuses are pulled out.
Yes.
And you're measuring current on the MET.
Well, even with the system fuses not pulled out, in theory, if you have a double in a domestic home, if you have a double pole isolator, you could effectively say that system is disconnected and separated from.
But the one on the Instagram, you had them pulled out. Is that correct?
Yeah, the one on the Instagram, the main, that was a 3-phase supply, and that was just for beyond a reasonable doubt. That physical link is gone.
Well, it helps the picture, doesn't it? The picture says 1,000 words.
Picture says 1,000 words. Now, this is where the issue gets really disturbing and slightly worrying, and I'm not trying to panic anyone listening to this. This is just our engineering logic and our thought processes here. The Definition of isolation is a disconnection and separation of all conductors in such a manner where they're secure, or there or thereabouts. So my earthing system should be defined at 0, not 0 volt, 0 something. Now, if I pick up energy in the form of amps, say 3 amps on that clamp meter, I have a charge. Now, at what point does that charge become of significant magnitude where it could give rise to danger? But also, if I'm picking up 3 amps, would I consider that a live part? And this is where it gets really interesting, because if you look at live part on page 32, it says a conductor or conductive part intended to be energized in normal use, including a neutral conductor, but by convention, not a pen.
Right, so that's just because the pen conductor is not considered as a current carrying conductor or a separate protective function.
Well, basically, what amazes me is that little play on words there is, and by the way, that that's been in there for a while now, but not a pen conductor. So the pen, protective earth neutral, is outside the electrical installation, which technically is outside the scope of 7671 because it's part of the system. So why is that referenced? What does by convention actually mean? Is that in normal? In normal use, we're not considering the pen conductor to be live. However, a protective earth neutral conductor, which is a neutral, is a line conductor, which is technically live. So why is it when it goes in our installation, it's a live conductor, it then goes into the DNO head, does it then become not live?
Well, part of it might be that if it's the pen conductor, if it's on like a Pme system, it's supposed to be connected to the actual mass of Earth at various points, so it should be at the same potential. Whether of course it actually is another matter entirely.
And that's one of the challenges, because I've seen lots and lots of cables jointed in my time, and I've never seen them drive a rod. And for those who are learning and remember their college days, I remember being taught that a TNCS supply has an earth electrode every 30 meters. Do you remember that? Every 30 meters there would be a rod driven down, and that was your TNCS, so it was safe as houses. But now we have effectively a TNS PILC system, which is converted to a combined neutral system in parts with no electrodes. So you can't say that this combined neutral and earth cable in the ground is actually PME, which means you can't regulate the potential differences along that cable. That's the problem. I believe the networks may not be doing what they're supposed to be doing. And I have photos, by the way, of a number of joints that have been done this year where I don't believe they're being done properly. And it worries me as to the state of the network, because I've seen roads dug up and there is more joint. I mean, I've shown you guys the pictures. There's more joint than there is cable. But if you think about it in that purest fashion, and also, by the way, in the DNO standards, we did a webinar where we went through this a little bit. But in the DNO standards, they themselves have accepted that a PILC cable, which is a lead armored bitumen wrapped cable, can serve as an underground electrode. But in theory, can it? Because it's not really connected to the general mass of Earth, because it's wrapped in an impregnated paper wrap, which is wrapped in bitumen, then in armored, then you get to another bit of paper, then lead. So it's not exactly going to be the most conductive of cables, is it? So we're kind of rethinking the way we look at this, maybe, Dave. This is just from me reading.
I'm going full circle. I'm still thinking about this. Going back, I mean, you mentioned obviously the pen, but if neutral is a live conductor because it's just a current carrying conductor, there's no potential difference to Earth there. It's just, I mean, I've had it before where I've broken neutrals on a light circuit, and the flash that you get when you break neutrals. If you've got enough current to cause harm to the human body, and it's flowing through a connection that you can open up, then that has to be considered as a live connection.
Well, Dave, lads, let me define a pen conductor in BS 7671, page 34, is a conductor combining the functions of both protective and neutral.
But that's if you've got
in the regs.
So if we isolate the system, we've got current flowing through our extraneous conductive parts like our Earth. due to diverted neutral currents. That doesn't mean it's PEN, because we don't identify it as PEN, and we don't insulate it as PEN. But it does mean it's dangerous if we open circuit it whilst that current's there, if that current is dangerous. Is that correct? If there's enough current there.
If there's enough current in a neutral, it's by definition a live conductor. We treat it as a live conductor. At the end of the day, the disconnection and separation of all sources of energy. Your live is your power in, your neutral is your power out. It's what's happening on the
diverted
outside.
Neutral.
Yes.
That's going through your earth metalwork.
Yeah.
If that amount of current is potentially lethal, then that has to be considered as a charge to a live connection.
Well, that's the thing. There's no definition, even though there's lots of references to significant amounts of energy. I mean, in HSG 85 mentions the level of energy, because at the end of the day, regardless of whether it's volts or current or power, it's still energy, which is transferring through a conductor. Nobody defines what the safe working levels for this is. I mean, I've actually been told that you will always get a level of power and current potentially when there's a damaged network flowing through an electrical installation. That's normal. But then I think to myself, well, I remember being a very pragmatic electrical contractor, and if I turned around to my customer and said, I can't isolate your station because if I switch off the live and neutral, I've still got power flowing through it. And that's the phenomenon known as neutral current diversion. Now, just to define, because I like defining, because people will criticize us if we don't. Neutral conductor is a conductor connected to the neutral point of a system and contributing to the transmission of electrical energy, which is great. The term also means the equivalent conductor of an IT or DC system otherwise specified in the regulations, and also identifies the mid-wire of a 3-wire DC circuit or the earth conductor of a 2-wire DC circuit. But effectively, if you cut out the last bits, it's a conductor connected to the neutral point of a system, contributing to the transmission of energy. Energy, transmission of energy. Where is the industry guidance on what is the safe level? And I'm not talking about just for humans, but energy, as you know, like from our podcast with lightning protection, can be the source of fires.
Ignition, yeah.
Cable breakdowns. If you have a cable, let me put it like this. Imagine you have a CPC, which you put a clamp around it and it's carrying 35 amps. And it's, I don't know, it's lights outside that, you know, someone's done a bodge and connected onto a copper pipe that goes into the ground, and it's finding a source, it's finding a route. That cable isn't rated. Say it's a 1 mil. It's not rated to carry that. So that cable is going to then be under thermal stresses, thermal strains, which will then potentially cause the conductor to break down, which could then cause the insulation to break down, which could then cause fires. And this phenomena is known as neutral current diversion. And it only occurs when there is a break or damage in the protective earth neutral of the electrical supply system. So you could have a damaged joint outside and you may be fine. It's only when there is a connected system of, say, 5 or 6 houses or buildings, where if you have one part of it damaged, you may find your return conductor can flow into an installation and back out to bypass the damage, the high impedance joint or lack of connection in the street. And that phenomena is being recorded more and more and more. In fact, if we look in Scotland, there's some statistics, Dave, I believe, that you've got for fires on electrical installations alone in Scotland. Can you tell us what they are?
Oh, God, yeah. This is from Ofgem, the SP Energy Networks. It says, according to fire statistics from 2011 and 2012, where the source of ignition caused an accidental fire, the electrical distribution accounted for 6,622 of them, which was 11% of the total fires in dwellings.
It's frightening, isn't it?
Well, it's when you quantify things that much, that's a lot, isn't it?
Well, we mentioned the other day that the DNO, like somebody asked us ages ago, why do we have electricity supplies outside of buildings now? Because it's easier for the DNO and cheaper. No, actually, there was a coroner's ruling that recommended that they go on all new builds outside. So if you have a new supply brought into your house and it's under the stairs, they'll put a cabinet on the wall. That's just what they do. It just removes the risk of fires. But just think of it. Just stop and pause for a second. We put now DNO intakes and metering equipment outside the building. Why? maybe because these stats say there could be a problem. Now, could there be a problem with the connections? Maybe I know everyone's screaming meter operators, poor installations, but could there, in older installations, be a problem? So there's a term I want to introduce people to in this podcast, and we'll have, or we'll talk about it in our next DNO webinar, or already have, depending on when this comes out, a term called phenolic, Phenolic. And there is a phenomenon known to the DNOs called phenolic degradation. And if everybody wonders what that is, if you haven't watched our webinar on DNOs, John Ward identified there were some lovely old cutouts that look like a human being with eyes and a nose, henceforth to be known as the JW cutout. But it's a plastic cutout which sometimes is filled with pitch, and there's like a cork bung in it. It's a brownish colour, dark brown.
It has that very unique colour that we've seen throughout our careers, because it's always been there.
So that, and just to be clear here, phenolic is actually a thermosetting plastic which is made from a phenolic type resin, which is then mixed with a wood flour filler.
Yeah, you might be more familiar with it. It's called Bakelite, which is
there we go.
Original type there, but it's basically the old black and brown plastic looking cutouts, and also the old black electricity meters, same material, and also the old brown and black Wilex fuse boxes, same material.
So what's happening to this material?
Go on, John.
Well, the key to it is in the actual description. It's a phenolic resin, which is basically some chemicals, and which set into like a hard plastic-like material with a wood flour filler. And there's various other fillers that have been used, but basically that is just mixed in there. And of course, flour and wood and other junk is perfectly fine when it's nice and dry. But if it gets a bit damp because it's been under the stairs in a damp house or something like that, that wooden flour bits can become conductive. And if it's conductive and it's connected to a natural installation, then of course current will flow through it, and it will char the bits and pieces inside, like the bits of wood flour and whatever else, and then it becomes more conductive. And when it's more conductive, you get more current, and then it becomes more conductive until eventually it turns into a blackened, charred mess and sets on fire.
Ooh. And that is, interestingly, I've been to a number of fires on DNO heads, and that phenomena, if you go to anyone in a DNO, they'll be able to look at a fire on a DNO head and immediately know it was because of phenolic degradation, where we now have current flow, you get tracking. There's some interesting experiments I know that have been done using insulation resistance testers across, because you can sometimes pick up on scorch marks across the surface where voltage will track across and cause damage. If you see that on a cutout, that's definitely a phone call to 105 and get the DNO out to change that. But it's something we're not told about. We're not
told about it though, because if we start identifying it, then there's going to be a lot of repairs to do.
Yes, I would say yes.
Yeah, I mean, what are the reasons then not to make us aware of this potential hazard?
Cost to the operators. Remember saying the DNOs are private for-profit companies. And the fact of the matter is, and I know what they'll say. They'll go, well, if our network is maintained accordingly, la, 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 and that's fine. And I'm sure they do, and that's all whoopee-doo. But the fact of the matter is there's still lots of fires that happen. There's still lots of fires. And I have never, ever seen anyone from the DNO knock on my door and go, hello, mate, I'm just here to inspect your service cutout and maintain it. What we are seeing is lots of electricians who report stuff, what they perceive to be a hazard. They then get a DNO guy out who goes, yeah, it'll be fine, or I ain't touching that, or you'll have to pay, or get an NIC electrician to put a rod in and an RCD. And it's been made worse. Ownership of the intakes of domestic homes have been made worse by the fact that now that the DNO, the main fuse, the main intake is owned, and the meter board is owned by a private company. The meter is then rented or leased by whoever you pay your bill to, and then the towers from that then go into your board. That's yours.
The problem with all that,
3 ownerships.
The problem with all that, the people buy the franchises to make the money off of the franchises. They don't pay for the franchises to then invest and upgrade and upmarket especially if there's no actual profit to make from it.
Absolutely. And don't get me wrong, there's a duty of care on them under the electrical safety quality continuity regs. We've covered this in the webinar. If you're wondering questions about earthing of BS951 clamps, we covered that as well in the webinar, because that was an acceptable practice. It was the oh blimey, what was the year of the 1984
80 something.
Yeah, it was basically, it's come out since the 60s anyway, but from the 60s to the early 90s, BS951 clamps were allowed. They were perfectly acceptable. Standards changed, but the duty of care was still on them, because guess what? They installed that cable. There may be a different company, but they're still part of the network, unless David, unless we then go into our definitions again.
Yeah.
Now, this is where it gets, for me, quite interesting, because if we look at, I'm just trying to remember the term now. What was it? There was that's it, 110. Do you know what? There's me losing it. It's because of my grey hair. I'm just losing 110.2, chapter 1, my favourite chapter, as you know, Dave. Exclusions from scope. Systems for the distribution of electricity to public. So why have I just spoken 2 references in that document that mentions pen and outside stuff, when it's part of that system for distribution to the public, which is excluded from scope?
Again, this is, I mean, the simpleton in me thinks back to those 3 drawings that we always used to look at, and we see that line where it goes from the intake to the consumer. We've always had that line in our minds, where the meter is, for example, where it suddenly becomes consumer, and it, where it's supplier and consumer. It was easy then, but a lot of stuff you're detailing obviously comes over into the consumer realm.
So let me challenge you on this, and I have asked this question. The regulations, it says 110.2, the regulations do not apply to the following installations, and the first one is the DNO. But it says systems for the distribution of electricity to the public. It does not mention intakes, does not mention cutouts. It's the system for distribution. Now, if I went to a distribution system operator and looked at their website, it would show me transformers, cabling as their system, and any other interconnections. Nowhere on that diagram would it say cutout. It would say we own the cutout, but under this regulation, systems for distribution, I could argue, and this is where the debate gets really interesting, I could argue that because my inspection schedule requires me to inspect the DNO equipment, which we did a coding webinar just on DNOs for that purpose. If I was a registered contractor and I did a rewire in a house and it was all good, and it was an old brown Bakelite intake, but it was fine, of new tails, new switch, new boards, RCBOs, all that good stuff. But it's a fire 2 weeks later. And it's not your fault. It's because of a phenolic breakdown, and a judge or a lawyer for your defense is trying to question you. They would say, did you notice anything on the DNO supply? Well, yeah, I noticed it was a bit, there's a few marks on it. Oh, okay. But you signed off to say that it was perfectly acceptable. And the electrical contractor will go, well, no, I didn't, because it's not part of the scope of 7671. But then the argument could say, but why does it say in 7671 that you have inspected all of the DNO equipment and it's fit for the alterations and protective measures? Plus, so that's visual, plus for the, what's the term? Availability of the protective measure, i.e. what do we need for our MCBs, RCDs to work? A good low impedance path. So to do that, we do a ZE, which is a test of the impedance of the electrical installation, as well as ascertaining the fault current values to ensure we've got low impedance, sufficient energy to trip the required protection. So if we're testing for that and we're inspecting the DNO equipment, you could, and this is just an opinion, argue in a court of law that the DNO equipment within the consumer's house is within the scope of 7671, as the exclusions from the scope states systems for distribution of electricity to the public. Doesn't define, a cutout or a main fuse. And given the fact that we're asked to take consideration of the intakes, I think there is a grey area.
It's very grey, because we technically still can't actually touch it.
No, because we're not trained or authorized to. I know some areas allow if you're NIC to do it, but the fact of the matter is it's competent, suitable for the task. And any DNO that allows someone just because they've got a badge to work on a piece of equipment that could be fatally flawed, then instant waiting to happen.
Yeah.
Now, we don't get much publicity of incidents and reports. We know from research that there are lots and lots and lots of phenolic breakdowns and thermal events, fires, whatever you want to call them. But it's just not shared with electricians. So if this is a bit of a brain melting podcast, apologies. Please check out the DNO webinars and all the other webinars where we do touch on this. We try to draw it out because we are still developing our understanding. Henceforth, we are developing a alternative method of questioning and trying to understand the logic using 7671 as our guide.
I think also in the more practical situation is that these cutouts or whatever else are in people's houses. If the electrical contractors are not going to be looking at them and saying, are these actually any good, who else will? Because, say, the DNO doesn't go around people's houses on a regular basis and have a look. And in the past, when you had your meter read while someone actually came around and looked at it, then that would have actually been inspected at the time. But, of course, how many times do actual meter readers go into people's houses these days? It's pretty much somewhere between occasionally and never. And obviously with the advent of smart metering,
well, I mean,
it is never.
We don't have a smart meter in our house, but what we have is our supplier gave us an app, and my wife gives the readings.
Yeah.
So we don't have a smart meter, but we've not had someone come in our house for 4 or 5 years.
Yeah. So that inspection thing, which used to happen quite often every year, has now gone away.
Gone completely, yeah.
So this is really interesting. So I was talking to someone about the electrical safety quality continuity regs of 2002, and he did mention to me very briefly, and it was I'd never thought of it like this, that there is a duty required of that law to ensure that the equipment and the system is safe, but the duty can't be put onto the consumer because the consumer is not in control, nor are they competent of the electrical installation. They can operate it, but that's what they pay qualified, competent, registered electricians to do. You know, they can functionally switch, they can do basic stuff. You can't say that they are fully in control.
How many electricians do you think have read ESQCR?
I'm not asking them to. Oh, don't get me wrong. Please don't take this the wrong way. This is us putting out different viewpoints and information for people to consider. But there is a duty on the distributor to ensure that equipment. And
that person who never goes in the house.
So here's one for you. So years ago, when I worked for EDF, when the safety quality continuity regs came out, EDF Energy spent millions understanding every single intake they had across all of their networks. It was a massive, massive task. They then coded it based on safety impact, criticality, etc. They actually found they had millions more intakes than they realized, and there was a lot to learn about their network that they'd lost from that transition of the electricity boards into private companies. Even now, if you speak to one of your jointers and any electrician who works an area, you know, whatever part of the country you're in, normally over time you will get to know your local lads, your local jointers. I mean, I've got to know my local jointers on my route that do railways and other stuff. They now know who I am and I know them, and that's great. But I want to. I
just want to read this paragraph from this fire report, if that's okay.
Go for it.
It's got the Electricity Supply Regulations 1988 and subsequent ESQCR 2002 provide the legal basis for the provision of electricity supply to the public of adequate quality and reliability with due regard to safety. In respect of the latter, Regulations 3, 5, and 24 make reference to the requirements for generators, distributors, and meter operators to ensure that their equipment is constructed, installed, protected, used, and maintained to prevent danger, so far as is reasonably practicable. I hate those words. Hence, there exists a duty of care for DNOs and electricity suppliers to ensure that their equipment installed within a consumer's premises, but which is not under the control of the consumer, is safe to use, and as part of the regulations remains so through a program of inspection and maintenance.
When's that happening?
Well, that's the key. I mean,
I've never say one thing.
I've never heard of a routine inspection strategy.
Boom. And there lies the problem. There lies the risk there lies the potential hazard.
But there's a huge assumption there.
So this is, but you can see now why 7671 has an inspection criteria on the DNO heads. It's almost like these committee guys have gone, yeah, we'll do you a favour, we'll inspect it. However,
is that what that is? Is the ESQCR the DNO's kind of?
Well, think about it. ENA sit on JPEL. ENA sit on JPEL.
Saying check those out for us.
Well, you could argue that the best way of doing it is when the electrical contractor is certifying the installation is fit, there's a requirement put on the contractor to do the maintenance inspection or give the visual inspection, and that would satisfy ESQCR. And in fairness, government would probably accept that. But the trouble is, in a court of law, for an individual civil case against an electrical contractor, you could argue the opposite. Is the electrical contractor's made the declaration of safety for something that the reg says is exempt, which is we know is the duty of care of the DNO. So is it being passed on to the electrical contractor and we are sitting at risk without having any knowledge of this? What we do know, just by buying a clamp meter and isolating electrical installation, if we've still got energy, you have charge. You have a neutral conductor, which is potentially diverting into your installation. If I'm to read to you, because you know me, Fundamental Principles, Chapter 13. No way am I reading my favourite section. The requirements of this chapter are intended to provide for the safety of persons. I'll miss out livestock and property against dangers and damage which may arise in the reasonable use of an electrical installation. If it's not reasonably used, okay, that's an interesting conversation. The requirements for the safety of livestock are applicable, but in electrical installations, risk of injury may result from shock currents. Shock current. Interesting term that, isn't it?
What else?
Excessive temperatures likely to cause burns, fires and injurious effects. Ignition of an explosive atmosphere, undervoltage, overvoltage and EMI disturbances likely to cause injury or damage. Mechanical movement of electrically actuated equipment, power supply interruptions or interruption of safety services, arcing or burning, likely to cause blinding effects, excessive pressures or toxic gases.
So does the presence of material like phenolic material push us into that? Do we think about that? If we see material that a bit of dampness might start resulting in a fire.
I'm going to put my common sense hat on. If I was walking into a house where there was a phenolic board and the installation was immaculate in every way and well used and cherished and maintained, and you could look at it and go, that looks like it was installed 2 years ago and it's 40 years old, I would say no, because the installation has evidently been controlled, well inspected, well cleaned, well maintained, etc., etc. If I looked into some of the rat's nests that we see regularly on social media, then I would suggest there is an issue there, and I might be bringing up the DNO and saying, I have a phenolic cutout, and I would like you to come and replace it with a GRP, which is the grey ones that we see now on most installations.
Yeah.
What's your view, John?
Well, how many domestic installations are actually maintained and cherished and kept in good order at all times?
I was going to say mine, but you called it a load of rubbish.
Yes.
So, yeah, the reality in domestic mostly is that it's installed once and it lasts forever.
But I'm just going to say it now. I'm going to throw it out because I'm really proud of it. You've both seen my wonderful front room installation, twin conduits to every socket.
Yep.
Beautiful.
Yeah.
Everything's clipped underneath. When I've done my intake, John, you must come back and go, here's Paul Mean's fuse board. It's a work of art. Michelangelo, well done. But at the moment, it's still a load of crap, but I'm getting there. Yeah, don't worry, I will get there. So much pressure on me from you guys. It's mind-blowing.
But so the reality is that most houses are not, unfortunately, done to those sorts of standards, are they? So
this equipment is vulnerable when it becomes exposed to moisture.
Yeah.
So a lot of the homes that's been installed over the years has been fine, but maybe there's been changes in energy efficiency. They've had extra insulation put in, or they've had some work done, and there's extra moisture or dampness, or something's happened where there's now an increase in moisture around the switchgear. Do electricians need to start considering things like that as to whether there's an increase potentially in the moisture in the switchgear's environment, or just it's there and it could potentially be dangerous?
Well, I think they do. I mean, the ones that I think the main concern is the ones that are under the stairs, because in the typical house, it's like your sort of terrace houses, that sort of thing, it was traditionally stuck under the stairs, and there's a little cupboard there, and that cupboard is usually stacked out with all kinds of junk and rubbish. And because it's under there, it's going to be a fairly cool bit of the house where you're likely to get condensation, dampness, all that sort of thing. And anyone who's been in any house like that and has dug under the stairs, yeah, it's quite common to find that there's a certain amount of dampness and sort of damp odours there. So, yeah, they're in these locations, and there is moisture present there. And even the ones on the outside in the meter box, those meter boxes are not sealed to some IP67 or anything. They're quite open in some ways. So
yeah, they're pretty pants, actually. Dave, I just want to quote to you the concise list of external influences in Appendix 5. Namely, ambient temperatures. You could have. I'm just gonna throw it out. I once went into a very good, close, and beloved friend of mine's home, and I asked him to go to the gentleman's convenience, which was under the stairs, and I walked into what could only be described as a miracle of compression, because within this under stair cupboard he had a shower and a toilet, and on the wall he had this. Basically, it was an old Wilex board, but a rather large old Wilex board, beautifully plywood around, and he had 50 amp breaker, 50 amp breaker, 50 amp breaker, 40 amp. He's an electrician, but he ran like arc welders and stuff and all sorts. So he just was like, yeah, I'm in control of the installation. But it was amazing to see, because I just thought, my God, when you're having a shower under a bloody staircase, it was a big size staircase, obviously, the amount of condensation, but he even had a little fan built in, and I'd never seen just so much compressed into a space. And that to me straight away, you could have, I'll tell you another thing, John. What happens in a lot of old houses, where when you start lifting up the boards, when you're doing a board change, straight away you'll see the old cable swooping in, and directly under the board, a lot of the times, there's an old air brick.
Yeah.
Which straight away, you're going to get external temperatures, external conditions very close to that. So your cable and your head is going to go through quite a dramatic temperature change. It's going to go through ambient temperature changes, humidity changes, and it's just something that we've got. Let's be honest about it. We're not geniuses on this. We're not rocket scientists, but I think there's a journey, there's a piece of learning we may need to do, because for me, and I think it's fairly evident of recent months, working inside of 7671 is great and dandy, but it's slightly blinkered. And I would challenge the industry to say we need more support in understanding the outside parties and how they influence and contribute towards the safety of our installation. And I'm hoping in future amendments to 7671 there is more advice on neutral current risk. I'm hoping there's increased criteria for buying an earth leakage meter and checking that before and after, so we can have safe systems of work. I'm hoping maybe that the industry will produce some guidance that says, please be wary of these phenolic ones, give us a ring, and we will put them on our planned replacement programs, maybe. But the DNOs do admit in all their documents, because we have acknowledged some of their documents in our DNO webinar, there are some, what do they call them? Not suspended, but there's a word that they use. They're like listed for immediate changes. So they have like a list of, I can't remember the term off the top of my head, I apologise. But they have a document that's a guide to cutouts. And in that, they show like the fused neutrals, the metal clad ones. And if you see them, it's a call to 105. It's a get this changed as soon as practicable, because it's a legacy item that they themselves have admitted is too dangerous or too hazardous.
Yeah, I downloaded the document about that.
But again, they do have ones that slip through, and they admit that in their document. They may not know every single cutout type and date of installation at every end point of delivery of energy. So, yeah, there is. We're going to have to learn more about this. Doesn't mean we have to go immediately and go, oh, phenolic is crap, it's crap, it's crap. But let's start developing our knowledge. Let's start having the conversation, and let's start debating it. Nothing wrong with that.
Exactly. There's no harm in that, especially if we're going to start basically committing to recording our observation of its condition.
Yeah, and the good thing about this is that a lot of these documents in the DNO about these things are available to download, and you don't even have to pay for them. They're free. You can just go and download them right away and look at them. So the information is all out there. It's just a question of going and getting it.
And just remember something for a PME installation, just back on neutral current diversion. Neutral current diversion has been identified by the DNOs, and it's also defined as current flowing in an electrical or mechanical path that is not part of the installation. That's how it's defined. Okay, so I'll say that again: current flowing in an electrical or mechanical path that is not part of the installation. So that's in itself is very interesting, because PME is always about not breaching potential zones, and yeah, it gives you a different way of thinking.
Well, I mean, the diverted neutral current needs to be acknowledged, and adopted. And right now, with the way we protect and we isolate and we identify and we test, none of that is integrated.
No.
So you can't just sneak it in as a new regulation. It's going to change a lot of the way we do a couple of things.
I think it's just more about, from a common sense hat on, I think it's one of the essential tools for an electrician's safe working is an earth leakage clamp meter, and doing some basic checks before and after. It's, to me, this is as simple as what we were recently discussing about the difference between different types of breakers and where you apply them. It's the right application of the right tool for the right job. And I think earth leakage meters have started out as a fad. I think they're just going to become a core part of electrician's toolbox, like a voltage probe and a proving unit should be in lock-offs. I think they're just going to be one of them sensible things. Now, before we wind this up, because we could go for hours on this, there is a fantastic document issued by UK Power Networks called Earthing Questions. So please Google it if you want a copy. And the experts at UK Power Networks, they own the underground cables and power lines in London, south east of England. And they've got a great little diagram again that shows what is PME. And it says PME will be available to all new houses, along with houses that have been rewired to conform with the 17th edition. Needs a little bit of updating. I don't know why they use the reference. They should always just say the latest edition.
They always just date their document when they do that, don't they?
Yeah, they shouldn't. They should never do that. This can be seen in Figure 1. Now, what they do state is, and they repeat it for clarity, because the maximum earth loop impedances is not in 7671. It's in the on-site guide. And they state that for a 230 volt single phase up to 100 amp, the maximum earth loop impedance is 0.35. For a up to 200 amps, it's also 0.35. For 400 volt three phase, above 200 to 300 amps, it's 0.2. And for 400 volt above 300 amps, it's 0.15.
Now, so the on-site guide is only for systems up to 100, isn't it? That's probably why we've not heard of these other ones.
Yeah, we haven't heard of these other ones. Exactly. The on-site guide doesn't go this clear. Now, there's a brilliant section in it which says, my electrician has done some wiring in my house and says the earth loop impedance is too high. And why wouldn't he? If he measures it and it's too high, it's a PME head. He goes to do an earth loop impedance and it's 0.5 ohms. And he's going to go, oh, well, that's just too high. So what it does state, and this is a golden nugget of information, it says often older houses have separate neutral earth, SNE. All earths are wired back to a separate earth block, which we would call our main earth terminal. And often the earth loop impedance can be higher. These values can be shown below. Now, this is where it gets really interesting because, as I said earlier on at the start of this podcast, I've seen installations where it's a TNS, PILC, but on the other side of the wall, it's PME. I then go and do a test, which I presume to be a PME supply, but the value is too high. So what they've said is 230 volts up to 100 amps. The maximum earth loop impedance is 0.8 for up to 100 amps. Up to 200 amps, it's now 0.35 for a PME. So we normally, for the domestic guys, we know it as 0.35 because that's what the on-site guide tells us. But the DNO tells us and since the 17th edition, the DNO has told us for a 100 amp service, which is every home in the UK pretty much, it's 0.8, which is the TNS value. And the reason being is because most of the network is TNS, as we discussed earlier on.
So does that mean the on-site guide, when it was updated to the 18th edition, should have had a change?
the on-site guide may want to do a bit more collaboration with the DNOs. Now, it says up to 200 amp, obviously 0.35, which is normal. That's for PME and PNB, which is protective neutral bonding. But on three-phase, Dave, it's up to 100 amp, 0.8, as the 230 volt one was. Up to 200 amps, it's 0.35. Over 200 to 300 amps, it's 0.2. And then for above 300 amps at three-phase, it's 0.15. So this is a golden nugget of information about PME maximum values, and I would use this because this is a networks issued document. It's clearly sits above the on-site guide.
It says
again,
it says in the on-site guide. Sorry for disturbing you. It says in the on-site guide, the values of 0.35 ohms and 0.8 ohms are typical maximum values as quoted by distributors of electricity upon inquiry, which will aid, for example, designs for new builds. So what you're reading from is a lot more concrete than typical.
It's the formal. Do you know what this is, Dave? This is the. If you ring them up, they'll always say 0.35 because you're assuming you're a house. Yeah. This is that formal. Actually, it's either 0.35, 0.2, 0.15, or 0.8, depending on the energy demand, because obviously resistance and current proportionate. Now it then states my electrician states that my earth loop impedance is above the maximum of 0.8 ohms. What can I do? And it then states UK Power Networks can replace the earth clamp and retest. But yet we see lots of people, including people who are customers of UK Power Networks, who are told we're not touching the earth clamp. There are documents that are issued and now put on social media where they're actually saying install your own rod and a TT. But that one statement acknowledges the fact that if there is a clamp that exists, they have a duty to maintain it.
What's this document called?
This is just Google earthing questions.
Earthing questions.
UK Power Networks earthing questions. If you Google that, it comes up as a one-page PDF you can download and print out. It is a great one to print out and have in the van, or maybe Dave, to steal your idea, stick it in your eggs books.
Yeah.
In the back.
Yeah.
It's a great piece of guidance.
Does it does it have like traceable references to the information that's in it?
It has the contact numbers for faults. No, what you would then have to do is go into the UK Power Networks library, start downloading them, but I will at this point defer people to our DNO webinar where we do coding. We start introducing people because I think that's enough now for this one to kind of salivate people, get people thinking slightly differently, asking questions, and yeah, just basically ask people to watch our DNO webinar.
So I have a question. I mean, assuming what we think we know and what we do know,
yeah, we don't know everything,
but there's stuff we do know that we can't quite say. Yes. Do you think maybe in 10 years' time, the earthing arrangement illustrations will look different in these books?
No.
No.
Not at all, because TNS, and that's a valid point, TNS still exists, but we are going to have to consider...
There'll be a huge comment about the specific intent of TNS at that point.
TNS effectively will only exists on private operated, where there's a local substation. And I'll be honest with you, so I'll give you a perfect example of TNS in London. Shepherd's Bush London Underground Station, we had a new substation put in. We had to buy that substation because the design required TNS. So the network made us buy the sub, and that made us exclusive for connections in. So we had a separate line, separate neutral, separate earth connection, all the way back to the star point and the transformer. That we can declare as TNS. We own that. We novated the ownership of that substation.
You're in control of that.
We're in control of it. But there are some commercial installations, some commercial industrial estates that will have it. But other than that, TNS, and I'll say this out loud now, TNS is pretty much a benign dead system. And if you just pay attention to the people jointing the street or talking to your local jointers, the minute that neutral and earth is combined on that old cable, you have the potential for neutral current to appear and neutral voltages to appear on your earthing system, but only under fault conditions. And we need to be very clear. It doesn't mean your earthing is dangerous. It means we need to consider the risks and hazards in the normal operation of an electrical installation and who uses it.
Yeah, I think the bigger thing, pill that's hard to swallow with this really is we've had a couple of editions now where we're having to pay extra attention to PME systems, and we have to over-regulate or add extra regulation to control or to exclude PME, and that's going to carry on.
Yeah, I think
722 and caravans and all this stuff. So now to find out that many systems that we actually that are apparently a TNS are PME, but undercover.
Yep.
That's my concern, because we might go, oh, it's all those regulations about PME don't apply for safety here because it's TNS, when actually it might be PME.
Can I hit you with something really controversial to kind of leave people to think about? If we don't have TNS anymore, and all we have is PME in the streets, and it's not very hard to find out. If we have broken pens or high impedance joints, how do our RCDs going to work? Because if we have a broken pen, we effectively don't have that. We effectively have on the primary side of the RCD a breach, neutral, and earth. Yeah. So how will it detect downstream? They won't work.
Yeah.
And we've gone mad on RCDs in the last few editions of the wiring regulations. We've gone RCD mad. So I want to leave electricians with that thought, and I guarantee you we will come up with some sort of unicorn device or something. But I think that one exists.
Yeah.
But I'm not going to mention it in this podcast because we'll talk about it offline. I think the one exists and it disappeared and it will come back. And no, John, it's not in your collection. So, yeah. Any other questions, or should we just wind this up?
I think we can carry on talking about this for an hour or so. So it's probably best we just wind this one up.
Yeah, definitely. So yeah, John, any questions? Final thoughts, feelings?
Yeah, I mean, I think I thought we spoke about the on-site guide earlier. Bearing in mind that, like all of these books and guides and everything else, they're all just information taken from a variety of sources. They're not the whole picture. They're just a little tiny bit of something. And really, you want to be looking at the sources of where that information came from, not just the actual book itself.
It needs to. I'll just add to that, John. It needs to be considered. Why are we not being shown all of this information, which John has correctly said earlier on is very much freely available? You know, maybe because other people are more interested in collecting that information and then just creating their own guidance on it.
I think we're not doing the work as the industry. But John, you're absolutely right, and I want to end this with being as professional as I can. So I'm going to read from the on-site guide, which I have a copy, and it states at the very bottom of the second page, while the author, publisher, and contributors believe that the information and guidance given in this work are correct, all parties must rely upon their own skill and judgment when making use of them. The author, publisher, and contributors do not assume any liability to anyone for any loss or damage caused by any error or omission in the work, whether such an error or omission is the result of negligence or any other cause. Where reference is made to legislation, it is not to be considered as legal advice, and all such liability is disclaimed. So basically, we've kind of written a book. We're not really responsible if it goes wrong.
So it'd be a bad idea for you to actually lean on this book.
Well, you could reference it and pray to God that it's correct. But remember, on the second page is the get out of jail clause. But it's a salient point. Use your own skill and judgment and use knowledge. And this is why the industry isn't. I don't know why the industry isn't sharing this knowledge. Probably because they're not ready for it, or they don't know what to do with it, or private for-profit companies can't afford to do something about it. And then that becomes the responsibility of the consumer and the homeowner and the contractor. If it goes wrong, the contractor is to blame, potentially.
Well, we had this. We also heard on the webinar that some of the actual DNOs are asking the clients to pay for the remedy.
Yes, they are.
Yeah,
it shouldn't happen.
It shouldn't happen.
The thing with the on-site guide is that although there's a lot of good information in it, bearing in mind that the on-site guide is coming up for 30 years old, and a lot of the information in the first one is still in the current one. So stuff can become out of date and maybe not as up to date as it should be. So
I don't know what you're saying, John, but I like it. No, it's a valid point. It's a valid point. Right, gents, time to end it. Love you and
Yeah,
leave you.
yeah. To next time,
thanks
guys.
very much. Click
Cheers.
do the subscribe stuff, and
Yeah.
till the next one, take care of yourself and each other. Bye bye.
Bye.
You bet.